Here's some rocket science part. I'm going to show this real briefly. I'm not going to go into great depth about it. This is the cam bearing installer we used to remove cam bearings before. I have put a cam bearing on here, and you notice that there's a groove for oil right here. I've also drawn a red line here, and I mount this bearing up. There's only one slot, and that slot has got to be lined up with that spot in the crank we talked about where it feeds oil to the cam and oils the camshaft. If you don't, you'll burn your engine up in a heartbeat. Put a bearing on up against this sleeve. I took a wrench and I tightened to expand this. This expands open to hold it. And it's expanded and it's tight. I'm going to take it, I'm going to put it down the engine very carefully. I'm going to line it up and I will show you how to watch that. Go through one bearing to the next one to the one that it's going to fit in. I've already done two. Now I'm going to show you something here. Look down in here, you can see where that cam bearing is ready to line up and go in. There is a channel. You can see, if you use a flashlight, you can see the channel where the oil comes up in the block and feeds that. Make sure that you're indexed at about 11 o'clock on a Ford. With the engine upside down, this position will be at 11 o'clock. And that's why I've got that red line canted over just a little bit to line up. You can see where that cam bearing is ready to line up and go in. There is a channel. You can see, if you use a flashlight, you can see the channel where the oil comes up in the block and feeds that. Make sure that you're indexed at about 11 o'clock on a Ford. With the engine upside down, this position will be at 11 o'clock. And that's why I've got that red line canted over just a little bit to line up my groove to catch that oil hole. Then I'm going to tap it in with a hammer, put it in place. And I'm going to watch that I don't put it in too far. And it isn't something you beat the shit out of. You do it gently. And you check it as it goes in. Take some force, but the right amount. Done carefully. And I want to stop when I get it centered in that bearing. It takes a little experience. You don't want to go too far, because the cam's going to ride full surface on it. And I'm going to unscrew my tool, leave the bearing in, and pull my sleeve out. Just like that. And I'm ready to put another one on. When you're done putting in all your cam bearings, you turn your engine back over. You come in here with a flashlight and you can look down one of these lifter bores and see that bearing. And you can actually verify that you've got that oil hole lined up, and then you can see the oil passage underneath it. Same one with this bearing, and of course this bearing here you check on the end. But that's how you make sure that you've lined those up and they got a good clear passage. You can see that you're lined up properly. Now it's time to do our next step, which is prepare to put our pistons in. I'm not going to put the bearings in yet. I'm going to put the rings on the pistons. Now remember, we talked about being extremely organized and clean and tidy, and we numbered our bench 1, 2, 3, 4, 5, 6, 7, 8. If you're doing the other brand of motor, it's going to be 1, 3, 5, 7, 2, 4, 6, 8. But anyway, we got everything laid out in order, and we remember that we can look at these numbers right here: 1 and 1, 2 and 2, 3 and 3. It's a good time to verify everything. Make sure we got the right halves with the right pieces and things are put together and they're clean. We want this to be just about as clean as we can keep it. And we're going to put in our rings. The rings I chose to put in this engine, I got them 5/1000ths of an inch oversized, which is not a lot oversized. But I want to check and verify on my box that they're the right one. 1.5 millimeter, 1.5 millimeter, 4.0 groove. That's the measurements I supplied of these grooves here. Remember, we talked about measuring them. Uh-oh, the box says Dodge Ford. I'm putting Dodge rings in a Ford. This ain't gonna run. Okay, here's a piston we're gonna work with. We're gonna talk about what is the top ring. Top ring. This is the top of the piston. You see that dot right there? That dot faces towards the front of the engine when you place the piston in the engine. That's always a common sign. You have a dot or a notch, it means it faces to the front of the engine. Therefore, we're going to call this ring up here the top ring, or the compression ring. This is the second ring, or the oil scrubber return ring, and the bottom one is your oil distribution ring, which is kind of funny, the kind of corrugated looking. When you take the rings out of the packages, you're going to look for a note or mark or lettering, and there is a dot on these. See the dot on that ring? Now this is the number 1 ring, which is the top ring, and that number 1 ring, top ring, has a dot on it. That dot faces up, so it goes on the piston with the dot facing up to the top. Everything is in reference to the top of the motor, top of the piston, front of the engine. Okay, fun with math. We got to set the gap on the rings. So we know that these rings in a manufacturer, and a standard rule of thumb is to have 4/1000ths of an inch for every inch of bore you have a piston. We have 4-inch bore on this engine because it's 302. We haven't bored it over, the figure would be 4.020. Well, we're going to multiply it by 4, straight up 4 inches, and we get 16/1000ths gap. That's how much gap we want to put on the rings before the ends of it meet, and I'll show you how we do that next. Okay, I took a ring and I stuck it in the bore, and then I did it very gently without cracking it. Then I took a piston and I pushed it down and I squared up that ring so it was square in the bore, and I used these ring grooves as a guide to do that. Now I'm going to take my feeler gauge and I'm going to go in here and I'm going to measure that gap. You can hardly see it right there. That little gap right there I need to measure, and I need to file this ring until that gap opens up to 16 to 18/1000ths. It can be 20, and it can be as little as 16. My goal is 18/1000ths on each bore with this top ring. Okay, here's some of the rocket science part of this whole project. I don't have my lab coat yet. Trust me though, I ordered one. We're going to put the ring in this ring groove grinder, and you set this up so that when you hold right here with your hand and you hold that ring like that, and you put some tension, you hold it here, put tension against it, and it comes over against that wheel. That little wheel has got diamond impregnated in it, and it doesn't seem like it does much. You turn it with the handle and you hold that ring against that, and it will actually cut that ring, and you can watch the little bit of steel pile up on that edge while you're doing it. And here's a good suggestion. While you're doing this, you're going to do this and go try to fit it in the bore, and it's not going to be enough, and you're going to come back and do more, and you go back and fit it in the bore and measure it, and it's not going to be enough, and you're going to come back and do it some more. And then one time you're going to do it too much, and you're going to go over to the bore, and you're going to have 22/1000ths gap, and that's not what you want. Learn to look at either the pile that's piling up here, or count the number of turns and try to be consistent with how much tension you hold on. You can say, I'm going to do 20 turns, and that's going to get me 1 or 2/1000ths, and I'll go over and look and see where I'm at then. And you'll get kind of a feel for it, and it'll go a little quicker towards the end of it. But I'll tell you what, you might spend 2 or 3 hours filing and fitting these rings in the bore. Don't skimp on this. This is your compression. This is what makes the engine last, what makes you develop horsepower. And if you get it too tight and you get some bad fuel, you could break a ring, hurt a piston. And if you get it too loose, you're not going to develop power, they're going to leak. Okay, and the time it took you to have a beverage and make a sandwich, I filed 1 ring. Can you see that little gap right there? That little gap measures 18/1000ths. That's what I wanted. I very carefully did that. Something else I want to talk about. Each time you file this, when you file it on that ring groove filer, that edge is going to get sharp. Before you put it in the bore and gouge something up measuring it, or when you finally fit it, take a file, just a little file, and just dress that edge that you've been filing on. Just drag it across it in one direction. I think that's what dressing is. My dad used to say that. He'd say, dress it with a file, son, don't file it. And that means to drag it in just one soft direction and just knock the edge off on the 4 corners, the 2 corners and the 2 sides, and make it nice and smooth like the other one is. And then when it goes in the bore, because you use that ring groove tool, those 2 edges are going to meet perfect and make a solid seal in that cylinder with 16/1000ths gap. And when the explosion goes off, it'll seal shut and hold and be good. This part will drive you nuts. It's going to be tedious, But what I'm going to do is I'm going to sit down, I'm going to put on some blues, take a little break. I'm going to take my time. I'm going to file each one of these rings. And when I get a ring done for that bore, because I honed, I want it to fit that bore, I'm going to leave that ring in that hole. And that's the hole it's going to go in. It's going to go in hole number 1, on piston number 1, and everything will fit exactly to the specs. Don't going to mix and match. Things got to go back in the hole they came out of, because we didn't actually machine this out to spec, so each hole could have a little bit of variance. Now, I'm going to take some time. I'm going to do each one of these rings to 18 thousandths. The spec really calls for up to 20, but I'm going to do 18. I'm just going to experiment a little bit and see how that does for me. I wouldn't go any tighter than 16 for sure. But what I'm going to do is I'm going to do each hole. Then I've got to go back and do the second ring the same way. It has to have the same gap according to the specs on these rings. You need to check each set of rings you buy. If you buy chrome mollies, they're different. If you buy total seal rings, they're done totally different way. But I'm going to go back and I'm going to do each one. I'm going to put it in the bore it belongs in, and I'm going to leave it there. Then I'm going to take each one out and put it on the piston and keep everything organized. We'll get back to that in a couple of hours after I get done filing all these rings till it drives me nuts. Okay, I've got all my rings gapped, and I've got 2 rings in each bore waiting on me to come get them. And I'm going to put them on that piston. They're going to go back in that bore because there's an 18 thousandths gap on this hole, an 18 on this one, and on this one, on this one. They might be a little different, but each ring has 18 in that particular hole. Now I'm going to put the rings on the pistons. And here's a chart I've got from a piston company. It didn't come in these instructions, but it specifically talks about where we place the ring gaps. And the gap on this little corrugated one is supposed to go on the right bank of the engine, which I'm going to take cylinder number 1 is on the right bank of the engine from the driver's position. The gap of the corrugated piece, the center piece, goes at 3 o'clock. And then a little thin one underneath it goes at 8, and the one above it goes at 10 o'clock. I'm going to put that ring together first, this little ring right here. That's the one I'm putting in. I'm going to go ahead and put all those together. And I've set myself up with some plastic coated holders in my vise, and I can put that rod in there, and I can put this piston in the vise forward of the engine. And then I got a good reference of 3 o'clock, 8 o'clock, and 10 o'clock. And get everything put together just right, and I can manipulate it and handle it without dropping it on the floor, and everything works good for me. Okay, I've got all the oil rings on, and they're on exactly as they should be. At 3 o'clock, 8 o'clock, and 10 o'clock. And they're all in order, back in their places, and I can verify by checking my numbers, make sure I got the right ones, the right places. And I've double check my chart, make sure I'm putting this at the right direction. I got number 1 back in there, and I need to put on my second ring next. I'm going to come over to my bore, and my second ring is the one up in here. I'm going to take it out, and that's for cylinder number 1 going on piston number 1. This is where you got to make sure you don't make a mistake, because this is where it fits. Now I'm going to take this, and I'm going to use these pliers, and I'm going to open it straight, and I'm going to lower it down and drop it into the ring groove. I'm not going to spiral it in. If you spiral it in, it'll crack and break. These are a fragile type ring, and I want to make sure that I've got the ring right side up. I'm going to look for that dot. There it is right there. That dot is right there on the left, and I'm going to line that up and put those on. I'm going to put one on each piston. Okay, I'm going to verify again. My dot is up. I'm going to take my ring groove pliers, which are cheap and affordable. Don't do this without them. I'm going to hold it back here, and I'm going to open that ring up so it goes down over the piston. I'm going to bring it down to the second ring. I'm going to set it in that groove. Go ahead and let it seat itself in. Make sure it goes and collapses and moves everywhere it's supposed to. At 9 o'clock, there's 12 o'clock in front of the engine. While I'm here and I've got this one in, I'm going to go ahead and put the other ring on as well. The other ring has a dot that goes up, and it's going to go at 3 o'clock. You got to be careful with these. The tension of these is crazy. You want to make sure that you get them in there without breaking them, because a broken ring ruins the whole project. You might get it in a bore and it might be just cracked and then it'll break and it won't hold compression. I'm going to do these pistons 2 rings one at a time out of the prospective holes in the bore, so I know I'm putting them in the right one. Who caught me say that? I said prospective holes. It's not, it's the respective holes. I'm from Kentucky. I'm trying to use big words, and I'm seriously challenged when it comes to that. I'm going to take the rings out of their respective holes and put them on their respective pistons so that they go back in their respective holes respectfully. Okay, tool time talk. It's time to put the pistons in the bore, and we need what's called a ring compressor. This is a tapered cone that tapers down to the size of the bore, and you set it on the cylinder like that with the piston in it upside down, and you push it in with the butt end of a hammer gently, and you try to miss down there on the throw of the crank with the bearing so you don't damage it. Well, these are 4.030, and these are my favorites, but they're 30 thousandths over, which means they're bigger than the holes in the block because I didn't have it bored and I didn't buy new pistons. So I'm going to use this old style adjustable one. You tighten it down with a ratchet, you put it on a piston, and you tighten it down till it's just right, and then you use it. It's going to give me some memories of my dad. I'll bet that's put in thousands of pistons. Holy cow. Anyway, we're going to use this one. I'm going to put some oil in here, and I'm going to dip the piston in the oil and get the rings all oily, and then I'm going to mount it in here and crank that down. I'm going to bring it over here to the block upside down and put one in, and I'll film that. Okay, I have to put in half the bearing to put this down in the engine, and I've inserted that bearing insert. And remember that tab we talked about? I pushed it in on this side first, and I pushed it down with my thumb till it locked in there and it's flat and smooth. Then I took my bearing pre-lube and my little brush and I lubed it, but I did not go all the way to the top because we don't want any in between here to take up tolerance. So I'm going to go to torque that cap down. Now this is something I'm going to do. I'm going to do one cap off, two nuts at a time, because the nuts are going back on the bolts they were on originally. The cap's going back on exactly the way it goes. And if you get confused about which way the cap goes, got a 1, got a 1 stamped right there. And we got to remember, when the piston goes into bore, that dot goes towards the front of the engine. You'll also notice when we get done that all these numbers are facing towards the center of the engine. Okay. I've got a piston ready to go in the hole. I have my bearing insert in. I've got it pre-lubed. I have this cinched down, and I dip the oil in the rings in oil first. Saturate them with oil. This is a messy part, and that's okay. Now, I need to remember, it's going to go in with the dot facing the front of the engine, and I've got the crank rotated down out of the way so that this should balance and drop right over it. And I also have a towel, a clean towel underneath, so that if that bearing insert falls out, I can save it and wash it and not step on it and bend it and everything else. Got me a nice rubber end on a hammer, and it doesn't take much to put this in. And I'm going to kneel down. I'm going to watch for that rod to come in. I can feel it right there. I'm going to hang on to it, and I'm not going to let it bump that crank and damage it or scar it. Some guys even put 2 pieces of vacuum hose on the sides of those bolts so that they don't scar up that crank bearing as they go past. I just tap this in gently, and look at that. Now that's home free right there. And there's my piston. It's in the bore, and I've got this rod right here. Now I can push this down with my finger, move this out of the way. There, now it's on the sides of it. And I'm going to push it down. I'm going to let you guys see this. I'm going to rotate this. Let you see how that goes in there. That's pretty slick, the way we try to do that. See, I've already got that balanced on that crank. I'm going to push that down and not lose that bearing insert. It's got to stay put until that comes down right to the bottom, real gentle. Then, doing a full 360 view, I'm going to take my cap, put a bearing insert, the other half of bearing insert in it. Now I'm going to put that on and put those nuts on finger tight. You ever wonder how that oil works inside of there? There's nowhere for the oil to get out. Oil comes out of these holes in the crank under pressure right here where I'm pointing to. There's two holes, one that feeds each one. There's two rods on each throw, and the oil pumps in there, and it pressurizes and floods this area between the bearing and the rod, and it rides on a cushion of oil, and it floods and squishes out between here, and squishes out under high force as it comes out. And when you talk about oil pressure, well, that's what we're talking about with oil pressure. Is that tolerance, letting that oil build up pressure in there to make that metal float with a barrier between it. And without proper clearances and things being just right, you lose all your oil pressure, and that oil's not there to protect it. And that's when things really start sliding downhill and you lose it all. So I'm going to carefully, well, if you drop one of these, just stop what you're doing and get a magnet and make sure the magnet has no metal filings on it. Don't add any metal to your engine. Get your old speeder. My dad used to be able to run one of these with his hands somehow. He would just take one hand and just spin that sucker. He could put a bolt down or a nut down faster than you knew what to even think. I am just going to barely turn these down. I just want to make sure that the gap gets taken up. Because when we torque these down, you're going to be surprised. They don't take a lot of torque. And they stay in that motor and turn 6,000 RPM and hold together. It only take about 28 pounds. Okay, I've got two in, sharing their spot, and I wiggled them, made sure they moved a little bit. Things are good. Question is, how do I get this turned? Okay, remember that washer and that big bolt that was in the front on your balancer? You put that back in here gently and put it in, and you take a wrench and you turn the engine. The engine always turns clockwise. And look at that, that should just turn over just so slick and easy. Because I like to go in order, I ain't scared to come all the way around down to here. Now the more I put it together, the more drag I'll get, but I tell you what, everything should be pretty smooth and rotate nice. You'll feel the drag of the rings on the honed cylinders. It'll feel a little sandy, but that's just your bore because you honed it, put new rings in it. Okay, let's recap where we are. We've got all the pistons put in and all the rods with caps on them, and I went through and I checked the numbers, made sure that each number was in the right cylinder and that each cap had the mating cap with the mated rod. I made sure that I pre-lubed each one, each half, and when I put them in, as I got the rod down to the bottom with the piston, I did more of a push than I did a tap. A push is much better because you don't knock that bearing insert out. I didn't have any bearing inserts fall out. And I made real sure that I cleaned them off underneath before I put the insert in with a dry towel. Remember I said we didn't want any oil underneath our caps, and my hands have been oily the whole time. So I'm constantly wiping underneath before I put a bearing insert in. So I got them all in, I put the caps on, I tightened them down finger tight with a speeder, okay? And then we're going to look here in just a minute and see. On the top end, we're kind of oily. We got oil on everything. I'm going to wipe a little bit of that surface off when I flip it over. And we're going to turn it up and down two ways, and I'll show you how it looks and how easy it seems to be. There is a way to put a torque wrench on it and check that. Okay, before I turn it over, I want to see just how everything feels. It doesn't take a whole lot. It seems even. There's no stiff spots in there. Everything wants to rotate smooth. The rings have all got oil on them. The piston skirts have got oil. They've distributed it on the cylinder wall, so it's okay to rotate it. I'm not going to scar it. Our main bearings are torqued, and they seem to be doing good, especially the thrust bearing. These are hand tight. They seem to be doing good. The poor dog is going crazy outside. He likes to chase birds in the evening, and he runs about 40 miles an hour chasing birds as fast as he can go this time of night. So I'm going to flip it over, and we're going to take a look at that side too, see how it is. Looks like it turns smooth on this side too. Everything going up and down smooth. Doesn't take a lot of force. It takes some. We can put a torque wrench on it and find out, but it feels good to me by my experience. There's no drag and no catches, no sharp spots. It just seems to move over even and smooth. That's what we want.